looking for a culvert where I can, this is a big canal we've got for irrigation for farming. I'm actually searching for a culvert where I can do control scans. Because I'm going to be testing our software again, of course, with our standard devices, the OKM scanner, metal detectors, then as well the new Octa 6000 pulse induction machine. And we're going to be seeing how each of those interfaces, along with my MindLab detector, how they each interface with our software, develop some methods, further develop methods, I should say, toward scanning procedure and all that stuff, getting it all knocked out. And so today I'll just be taking out the Rover C, which is an OKM device. This is the first generation, and we're going to be using a wireless mic setup for the first time, so no more cables or anything like that. And then I'm taking it into our latest edition of software, so this will be the first time we're scanning into the latest edition of software, which is a lot cleaner, runs a lot cool. So, all right, but that's what we're doing. So, come to a little mud patch. Hate to do that next to a 40-foot deep canal. That's really deep, but whatever. Stuck the old Eagle in 4-wheel drive. We'll see what she does here. These can be really bad, so. Wow, that's deeper shit on that side. Guarantee that was up to the hubs on that side. Wow. Crazy. All right, well, the Eagle does good. So I was able to find one culvert, and I think that's a big one. It's on the other side of the river over here. But I'm gonna take a look real quick. I think I just crossed another one. I want one 3 to 4 feet deep, and then I want one about 6 feet deep. But even if I can get 2 feet or 3 feet just for a control image where there's nothing else, that would be great. And this looks like this is a good contender. So this is a steel culvert. It's got about 24 inches on top of it. It's got concrete caps, but this is a great contender. So that's good. The water won't make any real difference, but cool. So the other one was like a 4-foot culvert. And it was back on the canal back there before the mud hole, or I'd go back and take a picture of it, but cool. We've hit a couple of pretty good mud holes so far. Here's another one, I guess. Hope it don't get stuck. The car's doing good so far. They ain't no telling how deep these are though. So, sweet. Pretty deep. I know we rubbed bottom. The car is good, man. This clay out here like that is like bottomless pudding. So when you get a hole like that, you can just go right to the frame. So I'm having to floor it to get through it, but yeah, it's doing good. Cool. So have found a couple of culverts that are gonna work. Oh shit. Oops, sorry. Went into a deep metal, almost pulled me into that hole. So found a couple of culverts that are going to work. Just have to probably come back out with somebody else so they can run the laptop. I could do it alone, but it's a little easier when you're doing control work and you don't want to, you want to make sure everything's hunky-dory, so to speak. So anyway, yeah, so that's going to work out. So this is a good little trip. Well, that was a fun little adventure. So going out looking for a culvert, found a couple of culverts that are going to work great. No problem. Be able to take it easy imaging. They're only about 24 inches deep. But that's cool because that's supposed to be outside the range of a metal detector, and we'll use a metal detector to scan both of those to get some imaging, and I'll bring the rover and maybe a 2-box or something. We'll start trying to put together some methodology. Yeah, you can see here behind me the car get its first little christening in New Mexico clay. So it did really good, actually. I'm impressed. Yeah, I know this side sank all the way to the hubs, and it still made its way out of there. So good car. Not too bad at all. Anyway, yeah, so we'll carry on. I'm going to go ahead and get all the stuff together to go out and get ready, and maybe get another hand to pull it off, and who knows, we'll see. If not, I'll just do it by myself. I don't know if I'll go to that same one or not. Those mud holes right next to that canal are a little bit sketchy, and cars have slid off in there plenty of times before, so maybe we'll go to that one, maybe we'll find another one, but we'll find something that'll work and get it up. Okay, so we're going to go ahead and scan a test subject here, which would be this culvert. It should be a still culvert going beneath this parking lot. It's going to give us about 24 inches up there on top of it. I'm hoping, actually, potentially this could be a concrete culvert. If it is, it's going to have rebar in it, but it's certainly not going to be. Let's see, is it concrete? Yeah, I think it is. All right, well, we're gonna scan it anyway. There should be, like I said, there should be rebar in those concrete tubes that are there. And what that'll do is that'll allow me to hit it with a magnetometer into the concrete. And or the concrete itself, this would be an interesting test, because the concrete itself is a shield or an insulator to magnetic energy, magnetic fields. The rebar is located inside the concrete, but I do have a linear feature here, and so we'll scan this with the rover, at least, which we have here, and then we're going to be putting on these wireless mics for our transmission to the laptop. So we'll have one of these hooked up to the rover, the other one will be hooked to the laptop, and that's what we'll send our audio data across with. So I have an edition of software here now that is the software edition we released, but Taylor's also really amping up everything at the moment. He's working on one that has a mode switch that you can go from a white theme to black theme. The white's the more modern stuff they've got going on. And then as well, he's going to also have some other stuff where we can lock the sliders and things so you can't do accidental touch during scanning, and a lot of other little stuff and changes in the logic and whatnot, so it'll be even better than it is now. So let me get the stuff put together and then we'll take a look. Okay, so you can see what we've done here. We've got a Saramonic wireless receiver, audio pumping into the Panasonic. And then we've got the rover over here, and we're going to be running the rover hopefully through a small volume control before I go out to my transmitter, because the gain on this thing is the output is so incredibly high in voltage that it messes up a lot of electronics. So I found I can run it through a Saramonic preamp, and I can turn it down and I can take care of that. And our software will allow me to clean that up so we can actually see that data coming across and we can get to where we want to. So let me get this thing fired up and we'll show you what's going on here. Okay, so now I've actually got it connected all right and everything. We've got our transmitter connected through a Saramonic preamp, so I can turn down this extreme volume that comes off there. I get a real high voltage on their speaker output for some reason. And then we have our receiver connected to our laptop, and we have our audio already going in. And so we'll crank on our unit. You can see it coming on there, producing audio a little. We'll go over to magnetometer, and then we're going to adjust this gain on the preamp down a little bit. not quite that far. We'll bring it up just a little, like this, and then we'll use the gain slider that's on our software, and we're going to cut down some of this frequency, and we'll raise it up so we'll get within our limit, and then we'll see what our numbers look like here. So you can see that's actual scan data coming across from the magnetometer now. So as I move the mag around, see? So this is going to give us what's going to give us our map. Now if I had been sampling during this, then I could very easily turn this into 3D information. And we're going to be sampling here in a minute. We're getting a lot of wind, which won't affect us anything. And I'll have to go through a bunch of steps. Since I'm here by myself, it's going to be a little more complicated. But the way this works, to start a scan, I'm just going to name it, since I'm in front of the old Kmart, I'll just name it Kmart for now, 01. So it's going to be scan 01. And I could put in the other information I need. And our rate, I'm going to go on the rover, I'm just going to set one per second. And my count is going to be, we'll do 20. So we'll do 20 lines. And then for a timer, I want actually my timer to be 10 seconds, so I have time to get into position. So this is our countdown to when our scan starts. And then the only thing we have to do after that is just hit this button, live scan. And we hit live scan and we're off and running, and begin our lines. And what it'll do is it'll do a countdown of 10 after I hit that, and then it'll start the scan procedure. And right now I'm going to go ahead and I'll get a stick on the ground, and to just kind of vaguely mark my scan area, and then we'll try to conduct our first scan. So it's going to be a pretty neat deal. I haven't done it with this version of the software yet. And you can see the analyzer works amazing. Taylor did a mind-blowing job. It's the best spectrum analyzer, literally the smoothest and finest filtering I've ever seen. For example, we have a lot of low end coming across here, and I'll show you real fast. Let's go ahead and start anew. So we have some low end here that was showing up, and we know that that's outside of our low range. So I can drag my slider over, and you can see I can just cut that low end off the bottom, completely off. And then actually we have a high range up here too, and I could use the high frequency cut, but I'm not going to. We don't really need to. We can leave it there. Once I start pulling data, you'll see what it does. It cleans all that up for me. But see, now I don't have that hard band on the bottom anymore to mess with the data. So our filtering is mind-blowing. I mean, it really is. It's pretty amazing stuff. So let me get our stick out here. So we're going to be using a hard surveyor stick. And what this is just a flexible stick. I use these for all kinds of science, data collection and whatnot. So it gives you just a really nice visual reference for what you're going to be putting down. This is only a 7-foot stick. I'm just going to use it to define one edge, and so I can remember where the inside of the pipe is here. And we're going to get way away from the car, and we'll get the stick laid out here. It doesn't go anywhere. Hopefully nobody drives over it. So there's our stick, and we'll get the stuff set up and I'll get back. So this is going to be the layout. You see I'm marking a 20-foot grid, and we're going to be walking basically northwest. You should usually do these things north, south, east, and west, whatnot, but we're not. So we're walking this way, catching this culvert going about right through the middle of our stick right there. So we're pulling off that and getting with it. Okay, here we go. We're going to try and conduct our first scan here. Now we're also going to add an audible tone that'll tell you what the countdown is. But if I walk one line real fast, you'll see a raise. that raises our culvert underneath the ground. So we are picking up the rebar inside that concrete. But also you'll see a big hollow here and some other stuff. This data, the software is going to turn this into some neat stuff. So let's do a scan. Ready? And we are going to go now. 9, 8, 7, 6, 5, 4, 3, 2, 1. Okay, now the only thing we need to do another line is hit scan again. 9, 8, 7, 6, 5, 4, 3, 2, 1. Okay, we'll run a third line. 9, 8. Line 4. Kind of get the picture. I'll finish this out and then go back. Okay, so I ran that scan at 20 scans long, 10 scans wide. So a 20 by 10, it'll be a rectangle, and our anomaly should be crossing the rectangle. And I already found treasure of all things. How cool, huh? Perfectly usable tool. So, but things like this on the surface will throw red spikes in the data. And that's great because we want to see dirty things all over our image and see what happens beneath that. We want to see this culvert regardless of what's sitting around and above it. We'll see what the AI pulls out. But I haven't looked at the scan yet. I'm about to right now. We'll just pull it up. I'll show you how easy. So we just finished and walked over here. And we know we named it Kmart 01. So let's just go ahead and Kmart 01. It'll always open to where that first file was stored. And boy, look at that. So guess what this is? This is our concrete culvert. See if my camera's showing it, but this is our, see if we can do this way. There we go. This is our concrete culvert right here. You can see it in the data crossing clearly. We've got frequency spikes pretty high on it. Now let's open an amplitude map of the same scan. And now we've got a drop in amplitude. That's because it's concrete. See that? Okay, so we have a raise in from the iron in it and a dip from the concrete in it. So let's bring up the 5D chart now and let the AI play with this a little bit and see what this comes up with. Doesn't take long. And there we go. So there is our pipe running across the anomaly. Now I didn't walk the data straight, so you can see these are the changes in my timing. So it's real easy to see here, but there's it would be a straight line if I had done this, taken the time and done it right. It'd be a straight line. Let's go ahead and turn off the low amp so we can just see the data spike and what it looks like here. Beautiful imaging though, super clear. And that's a concrete culvert now. That's not a steel culvert. So let's go ahead and play with it a little bit. We'll turn on some low amp. So we've got probably water soaking around it down there because our high frequency response setting would indicate that. But what we're gonna do now is we're gonna go and switch it to the amplitude map here, and then let the AI work with amplitude, which is a whole different Oscar. And so you can see here we've got the insulating properties to the pipe going across in amplitude, and it does seem on that side there's probably pooled water out on out here. So it looks like we've got our pipe going under here like this, and then right in here we've got where it's either leaking water out the pipe or there's a lot of pooled water inside the culvert right here, and that's pretty clearly evident. So yeah, you can see how the software works. Now we can take it a lot farther than here. We have all kinds of filters and things that'll work with this data to show more information. And like I said, if I had walked this a lot more even, which I don't really care about because all I'm doing is just test and response, then this would be absolutely straight lines. Now what we can do though is we can give it a little bit, see our lines on the bottom, and then we can change our depth readings on this, and we can bring up different anomalies with the depth reading on the bottom. And I was trying to see if we get anything to come all the way over. Yeah, and so we're gonna also, I need to fix how this grid aligns, because apparently if I use a depth filter it wants to reset the grid, and that's not exactly what we want. So I mean, either way it doesn't matter at this moment. We're still in development, but it is amazing how well this thing actually works. You know, it's really crazy. So I'm going to call that a successful test, and yeah, we'll wrap this stuff up and we'll call it. I might hook a metal detector up to it. Metal detector shouldn't do anything on this, and it'd be nice to see just what kind of data comes in. So maybe before I take off I'll do that, and if I do, I'll throw that data up on here and I'll let you take a look at what the metal detector returned. Okay, now what you see is data coming off the MineLab Go 60. So we're going to use this metal detector, and you can see when I flash over the bumper here, you see we get a signature coming around. It's about 940 hertz, and when I go over the legs down here, the stand, it's 129 hertz. And you can see our amp level. And so now we're going to scan this culvert, which is 24 inches deep concrete culvert, with a handheld metal detector plugged into the unit, and we'll perform a scan with this. So let me go ahead and perform the scan, then I'll get back. Okay, I've just concluded the scan with the MineLab Go 60 metal detector, and which we've now, by using our software, converted into a ground scanner. And I have not looked at the data yet. This isn't it. This is the last file. So we'll look at the data now. And there we go again, instantly. You can see that's our culvert right there, mapped out really beautifully. We'll put it in the frequency file, our chart. Okay, 2. Oh, it's because it's named by the same name, and I'll have to open a different file first, and then we'll go back to that because I still had it in the memory under. Okay, so this is, there we go again. Dramatic example. This is our culvert. Remember, this is a concrete culvert 2 feet deep, just imaged with a handheld metal detector. Well, let's throw it in the 5D. Ooh boy, is she pretty. So we'll take a look at that right there. And we've got low amp on, we'll turn that off. You can see there's our, that's our culvert signature though. Beautiful. And walked my lines are off, or it would be exactly a straight line. You can see where each one of my lines are kind of off there in the data. So let's throw on one of each, high and low. Let's get our clearance a little bit. Maybe we'll change our map heights. so we can take a look at that a little better. Anyway, yeah, you can see, no problem. It means you can image with a metal detector or whatever. And I haven't played with this much. We could do a lot of analytical work, clean these lines up, get the computer to show us more definition. But it's actually, I mean, it's an absolute straight line. That's a wonderful thing. So cool. So that's ground scanning with a MineLab Go 60. All right, well we're gonna call all those successful tests, and we're gonna wrap this thing up. I'll package it and I'll shoot you guys out a video. Cool, have a good night.